Statistical Concepts by Kira O'Neill. So to begin, in order to truly interpret and understand statistical concepts, we first have to understand what statistics is. So statistics is a branch of applied mathematics that involves the collection, description, analysis, and inference of conclusions from a quantitative data set. The statistical concepts of mean, median, mode, and so much more are tools used by mathematicians in order to fully interpret the data sets that they have. There are a lot of questions when it comes to these statistical concepts. How do you find them? What are they used for? How do they differ from one another? And these are the questions that we hope to answer today. We're going to be starting out with a pretty well-known statistical concept, mean. Often referred to as the average of a data set, mean is the intermediate value between those of the set. The mean of a data set is found by adding together all of the points in that set and then dividing it by the number of data points in said set. One way mean can be used in real life is through taking the average of test scores. So let's say we have a student with a final coming up and she just wants to figure out her average score at the moment to see where she stands. Her first step is to write out all of her test scores and count how many data points she has, in this case 8. The next step is to add up all of these test scores and then divide them by 8 to get her overall class average or final grade in the class. Another important statistical concept is the median of a data set. There are a couple different ways to find the median or middle number of a data set, but the simplest seems to be with this formula here. You take the number of data points in a data set and divide it by 2. Then, if this resulting number is even, you find the average between that number and the one immediately above it in the data set. If it is odd, then the value of that number is the median. The median of a data set is often used in skewed data. For example, a housing market with 1 or 2 very, very expensive houses that offset the average. So when given these house data points, the first step is to rewrite them in ascending order from least to greatest. The realtor would then count the amount of data points and divide that value by 2, rounding to the next whole number. In this example, it's 4, so then the fourth value of the data set is taken, and that value is the median of the data set. The median house price in this county is $67,000. Moving on to mode, also known as the most common number in a data set. The simplest way to find the mode of a data set is to just count how often each number in the data set appears. An example in where mode would be used would be cars purchased by age. Getting a driver's license, graduating college, or becoming an adult would all be different reasons that happen at a specific age that would cause someone to buy a car at that time. However, averaging them together would not retrieve a result that shows the same thing. Let's say that a car salesman is trying to figure out which age group to market his cars towards. He would list out the age of all of the people who had purchased cars in the past week or so, and then tally up which age group is buying cars the most. His mode comes out to 16. The reason mode is used in this scenario and not mean is because mode accounts for the qualitative circumstances of the fact that many 16-year-olds are buying a car because they just got their license, and having children, graduating college, and other life events are what contribute to these purchases as well. There is no real reason why an influx of 19-year-olds need a new car, so marketing towards them simply because they meet the mean would be ineffective. Max, min, and range. The max of a data set is the highest value point in that set. Likewise, the min is the lowest value point. Oftentimes, these concepts are used in economics in order to maximize the profits or to minimize the cost of a product. However, they can also be used in another concept called range. Range is found when the minimum is subtracted from the maximum. Range is used to measure the variation and oftentimes accuracy of the data. So, say a meteorologist was trying to figure out the variation in weather over a couple of days. He might list these data points in ascending order and then find the max and min. Here the max is 53 and the min is 2. He would then subtract 2 from 53 and find that there was a 51-degree range in weather over these couple of days. Variance is another statistical method used to measure variation. Variance measures how far each number in a dataset is from the mean and every other number in the set. Variance is found through subtracting the mean from each point of the set, adding these values together, and then dividing them by the number of values in the set. One area of the real world where variance might be used is in clothing hem length. If there's a high variance in hem length, then the company might want to check their machines to ensure that they're functioning properly. Knowing the variance of this hem length will ensure high quality products for the company. The first step of finding the variance of a data set is finding the mean, the process which we went over earlier. As you can see here, the mean is 6. The next step is subtracting the mean from the individual hem lengths. The factory manager would then add up these values, getting a result of 26. He would divide this result by the number of data points in this set, in this case 4, and get a variance of 6.5. Now, standard deviation has quite a bit in common with variance. Standard deviation is a statistic that measures the dispersion of a data set relative to its mean. If this equation looks familiar, it's because the standard deviation is just the square root of the variance, which we just went over. Continuing with the hem-length problem, if the factory manager wanted to find the standard deviation of the dataset, he would have to find the square root of the variance he already calculated. This gives him a standard deviation of 2.55 inches. Quartiles. Quartiles are 3 points in a dataset that divide the set into 4 quarters. There is the lower quartile, the median, and the upper quartile. I wanted to take this time to talk about another median formula, which is the number of data points in a set divided by 2. And you can apply this logic to the lower quartile and upper quartile values as well. One example of how a quartile is used in the real world is in salary distribution within a company. The first step of finding the quartiles is the same as the median, writing out all of the numbers in ascending order. There are 11 data points in this set, so the staff manager does 11 plus 1 divided by 4 to get to the lower quartile. The median and upper quartile are found the same way, except instead of multiplying 11 plus 1 by 1/4, the manager multiplies it by 1/2 and 3/4 respectively. Final reflections. Once you have all the tools necessary for statistical analysis, it's important to know how to use them. Some statistical concepts can be used in similar situations. For example, if you want to see how varied data is, you can use range, variance, or standard deviation. In other situations, one tool might be completely unhelpful. Knowing the mode of test scores isn't particularly important. It's important that you fully know and understand these tools so that you can decide which is the right one to use in a given situation. Thank you so much for watching. I hope you enjoyed, and I hope you have a great day. Bye!